Welcome to part 4. We're going to be going through questions 19 through 24 on the multiple choice section of the Geometry Common Core Regents. That is a mouthful. Without further ado, let's do this. As shown in the diagram below, it tells us that AB and CD intersect at E and AC is parallel to BD. Okay? Now, if we know that's true, then we actually know that we can mark up some angles right now. So I could put vertical angles right here, and then you might remember this, but if these two lines are parallel, then I also know the alternate interior angles are congruent here. You can even say that these are congruent also. Those are also alternate interior. So this is angle, angle, angle similarity. But look at this, they even tell you it's similar. How nice of them. Given that AEC is similar to BD, which equation is true? And that just, when you have a question like that, it's just asking you to like match things up. Now I'm going to show you a trick to doing this that's going to change your life for the Regents. So this is level 3, similarity. All right. Now, check it out. What we're going to do is first redraw the triangles. That's always the first step. We don't like this setup. So I'm going to draw a big triangle. That's going to be AEC. All right. And then we're going to draw a small triangle. And the key to doing this is always make sure that your angles correspond correctly. Angles must correspond correctly. All right, they're not randomly done, they're done in a specific way. So we know that A corresponds to B because they both have that double marking. We know that E corresponds to E, obviously, and then we know that C corresponds to D. All right, those are just because we know the markings are the same, right? We have E has the 1 mark, A has the 2 marks, and D has the 3 marks. All right. Now check this out. Here's a fun way to do this. What we're going to do is actually just put in our own numbers, okay, to figure out which one of these ratios is true. So you're allowed to do this. You could just make up numbers. So I'm going to call this triangle a 2, 3, 4 triangle. And now I'm just going to double all the numbers. Remember, the ratios have to be the same, so I'm just going to double everything. So let's just make this 4, 6, and then 8, right? So I just doubled the numbers. Now, if we do this correctly, what we should do is actually get proportions that are the same. All right, so we'll just test them all out, and that'll be pretty straightforward. So the first one says CE to DE, all right, CE to DE, so that's 3 is to 6, all right, is equal to EB, which is 4, is to EA, which is 2. So let's see, CE to DE, good. All right, so I plugged that in correctly. Now, if on this side of the equation, what we get is 1/2 or 0.5, all right? If you put that in the calculator, you get 0.5. But on this side, we get 2. Since that is not the same ratio, the first one's out. We can cross this out by 1. All right, let's try this again with 2. AE is to BE, so that's 2 is to 4, as AC is to BD. Now, if you put those in the calculator, you get 0.5 for this one, and you get 0.5 for this one. It already works. That is the exact answer. Now, if you don't believe me, test out the rest of these and see if they also work, right? So if we tried 4, I bet you wouldn't get the right answer. But I'm not going to waste your time with that. I think you could do it on your own. All right, number 20. This one is a triangle is dilated by scale factor 3 with the center of dilation at the origin. Which statement is true? So this is a level 1 question about transformations. All right. So here's something you should know, okay? So we know a few things about dilations, right? We talked about this in the level 1 review, but we know this. 1, slope of image is always equal to the slope of the pre-image, all right? That's always true when you dilate a line. All right, and that means the lines are parallel. The image is parallel to the pre-image, all right? So we could put a little note there that says parallel. That's a big fact about dilations. 2, we know angle measures are preserved, right? We've said that before. They stay the same. And 3, we know the side lengths actually increase by or decrease by the scale factor. So side lengths multiplied by scale factor. So this one's saying which one of these is true. And let's say this. The area of the image is 9 times the area of the original triangle. That could be true. Number 2, the perimeter of the image is 9 times the perimeter of the original triangle. Okay, so that's also something we should look at. The slope of any side of the image is 3 times the slope of the corresponding side of the original triangle. This one we could positively say is out. Let's take this one out. And why? It says the slope of any side of the image is 3 times the slope. Well, we know the slopes stay the same, so that was definitely out. And then it says the measure of each angle in the image is 3 times the measure of the corresponding angle in the original. So that's just saying that the angles get 3 times as big, and we know that the angles stay the same, right? We know that. So these two are out. The slopes stay the same and the angles stay the same. So now we're down to a 50-50 shot. It's either the perimeter is 3 times as big or the area is 3 times as big. And I'll tell you this. Number 2 we should take out because the perimeter will also be 3 times as big. I could do this again. We'll just make our own dilation. So let's say this is our 2, 3, 4 triangle again. Now, if we dilate it with a scale factor of 3, we would get 6, 9, 12. And let's look at their 2 perimeters. And you're allowed to do this on tests. You could just test things and see what works. That's a big thing in this geometry Regents. So this would be 9, and this would be 27. And what you see here is that the perimeter is also 3 times as large. And so the answer is number 4. The area is 9 times as large. And I'll tell you this, the area increases by the scale factor squared. I'll put that here just in case you're interested. Area increases by scale factor squared. Okay? Now, let's keep moving. We're doing a great job so far. Number 21, the Great Pyramid of Giza was constructed a regular pyramid with a square base. That's probably going to help us, and that square base is going to help us. If it was built with an approximate volume of 2,592,276 cubic meters and a height of 146.5 meters, what is the length of one side of the base to the nearest meter? Well, I'll show you just how to do this. First, write out your formula. Volume is equal to 1/3 base times height. We're going to sub in what we know. We know the volume is 2,592,276. So we're just subbing that in for volume. 1/3 stays the same. All right. And our height is 146.5. Now for base, what we're going to substitute in is this. We know the base looks like a square. So the base is always the area of the base, and so the area of this base will be the side squared. So that's what we're going to solve for here, side squared. See, we're substituting that formula in for our base. So now what we're going to do is actually just do a little bit of math. So we're going to simplify this side of the equation. 1/3 times 146.5. We'll bring that down. 2,592,276 is equal to, let me put this in my calculator. Give me 1 second. I'm sorry. It's going to take me a little bit. So 146.5. 1/3 of that is 148.33, and that goes on. So it's 143.33 side squared. Well, to solve for side, we're just going to divide by 48.33. 48.33. So 2,592,276 divided by 48.33 gives us 53,636.9957. And that gives us side squared, and we'll just end off by taking the square root. Check this out. And what we end up with is 231 or 230. Biggity blow. Easy stuff. That was a lot of fun, don't you think? I said, don't you think? Anywho. All right, let's keep moving. That was a pretty straightforward one, but it's always important to write your formulas down. Oh, and by the way, this is a level 10 question. Let's always write that down. Level 10, 3D measurements. All right. Okay, last 3 questions on multiple choice, that is. A quadrilateral has vertices with coordinates -3, 1, 0, 3, 5, 2, and -1, 2. Which quadrilateral type is this? This is what I would say is this. This is, first of all, a level 8 question, applications of coordinate geometry. And I'll tell you this, I don't think we'll ever see a question this easy again. This is just basically saying, take out a graph, plot your points. And if you plot your points, it's going to look, and I'm giving you a terrible view right here, but it's going to look something like this. All right? And I'll tell you this, that's not a square, it's not a rectangle, it's not a rhombus, right? Because opposite sides have to be parallel in all of those. It turns out to be a trapezoid. You just had to graph it. So this is just one of those, you know, graph it. You have a piece of graph paper on the Regents, just graph it. Just graph it, bruh. All right. In the diagram below, ABE is the image of ACD after dilation centered at the origin. The coordinates are, here are your coordinates. What is the ratio of the length BE to CD? Now, there's two ways to do this problem. We have BE and CD. All right, so we're just trying to get this ratio. It's basically your scale factor. BE over CD. All right? Now, there's two ways to do this. Number one way would be to use distance formula. So you could just plug in the points for B, plug in points for E, find out what that is, right? You get that length. You can find the length using the distance formula, and then do the same thing for D and C is a decimal, but you can easily get that. So just take your time, use the distance formula, and figure that out, all right? That's one way to do it. Oh, sorry, this is level 1 transformations. And I think that's probably the best efficient way to do it. All right, just get those two using the distance formula and put them right over each other. Just asking for the ratio of the lengths in your given points. All right, so let's do that. So we're gonna figure out what BE is by using the distance formula. All right, it's x1 minus x2 squared plus y1 minus y2 squared. And then we're gonna do the same thing for CD. Square root of x1 minus x2 squared plus y1 minus y2. So it takes a little bit of work, but guess what? That'll get your answer. So if you do this correctly, the ratio of BE to CD is, well, we get BE is equal to 5. All right. And then we just have to get our length of CD. And this is over 7.5. And you can actually reduce this, 5 over 7.5. You could divide both of those by 2.5, right? And so that actually equals 2 over 3, all right? Or you could have just put that in the calculator and see which fraction that's the same as. Now, I just want to mention one other way to do that. Because this is a dilation, the ratios of all the sides will be the same. It doesn't matter which sides you check, right? The ratio of EB to CD is going to be the same as the ratio of AB to AC, which is the same as the ratio of these. Remember, similar sides have all the same ratios. So the much easier way to do this was to just find the length of EA, which is 4, and then find the length of AD, which is 6. And so that's just 4 over 6, which is also 2 over 3. Doesn't matter which sides you check, they will all have the same ratios. And then we have number 24. Line y equals 3x minus 1 is transformed by a dilation with a scale factor 2, centered at 3, 8. The line's image is. You know what we're going to do? You're going to take a little trip with me. We're going to do this on a piece of graph paper. Okay, so let's take this information and roll with it. Hold on one sec. The answer here is, quite simply, right here. All right, that's it for this one. We'll move on to the short answers after this. Peace. So you're given this lovely piece of graph paper in the back of your book, and you should use it for questions like this, as we did on one of the other ones where you had to identify the shape. So this is what it's given. We know that y equals 3x minus 1 is our shape, is our line, and we're going to dilate away from the point 3, 8, and our scale factor is 2. Now you might remember, all you have to do is start by graphing your point. So -1, we go up 3 over 1. I'm just graphing my line as I would, all right? Just, drew that point wrong. Okay, so we just draw our line. Beautiful. Now, we're dilating away from 3, 8. So we go 3 and then over to 8. And if you look here, you might remember this beautiful point. That's going to save us a lot of work. If the center of dilation is actually on the line, then the answer is the line itself. I'm going to say that in words. If the center of dilation is on the line, the equation of the image is the same as pre-image. That's it. The slope, we know, always stays the same. The y-intercept doesn't change, so it's just going to be 3x minus 1. So let's go back.